Good morning, everyone. My name is Morgan Keefer, and I've been working with A2LA for about 3 years now. Today I'm going to be talking to you about accredited methods in cannabis testing. These are methods that are being used by the compliance testing laboratories across the country. So first I'm going to talk a little bit about A2LA, who we are, what we do. We're going to get into the international standard requirements for method validation, as well as talking a little bit about the matrices that are available for validation, state requirements, method variability, and potential causes of method variability, as well as some ideas for the path forward. So A2LA is a nonprofit, non-governmental, third-party, independent accreditation body. We operate in all industries, including cannabis, but also including industries like petroleum, automotive testing, electrical testing. So the international standards essentially are not industry-specific. They're actually built to operate across all industries. The standard we're talking about today applies to testing and calibration laboratories, but we also do accredit proficiency testing providers, reference material providers, product certifiers, and more. A2LA was founded in 1978. We have around 115 cannabis testing laboratories, and we are the 5th largest system in the world when it comes to offering accreditation services. We do have ongoing relationships with various federal regulators and some state regulators as well, primarily in Maryland, where we are based. So the ISO standard, as I mentioned, it applies to all industries. And so Section 7 is about the validity of results. It's about method validation and method verification. So I wanted to put up what the actual ISO requirements are for this. The laboratory shall verify that it can properly perform methods before introducing them by ensuring that it can achieve the required performance. Records of the verification shall be retained. If the method is revised by the issuing body, verification shall be repeated to the extent necessary. So this applies to standard methods, methods that are already published, and this is something that is necessary for validated methods, but when you're actually performing a method validation as a testing laboratory, there are additional requirements listed in 7221. So the laboratory shall validate non-standard methods, laboratory developed methods, and standard methods outside the intended scope or otherwise modified. So as it relates to cannabis, this means that a lot of standard methods are published to be used on the matrix of hemp or maybe hemp and cannabis flower. So if the methods are to be used outside of those matrices, the laboratory will have to validate that use. The validation shall be as extensive as necessary to meet the needs of the given application or field of application, and the performance characteristics of validated methods as assessed for intended use shall be relevant to the customer's needs and consistent with specified requirements. So as you can see, these are pretty generic, widely applicable requirements. There's another, 7224, the laboratory shall retain the following records of validation: the validation procedure used, specification of requirements, determination of performance characteristics, results obtained, and a statement on the validity of the method detailing intended use or fitness for intended use. Again, this is very generic and widely applicable because it needs to apply to testing of automobiles, as well as cannabis and petroleum and food and pretty much every industry that we operate in. So there are some obstacles to method validation in cannabis. And I think a lot of folks are familiar with what these obstacles might be, the primary one being the federal illegality of cannabis and the lack of ability to cross state lines. This means that a lot of laboratories are not actually able to have validation materials on site when they're performing their initial method validation as a startup laboratory. In contrast, the compliance samples that laboratories are actually testing are very heterogeneous. So I do have just kind of like a circled example here where the diamonds and sauce are. And so you can see that's like a pretty heterogeneous sample. So if you're taking a really, really small subsample of that to test for terpenes or for cannabinoid concentration, it's really going to depend what subsample you select unless you fully homogenize that sample prior to testing. This is Not the case when it comes to most of the materials that are available for method validation, because a lot of laboratories are not able to have such concentrated products on site prior to initial licensing. This issue becomes exacerbated when additional creative products enter the marketplace, such as granola bars and Chex Mix and gummy worms and brownies, and we've even heard of temporary tattoos, and of course there's topicals and things like that as well. So there are so many matrices available now to consumers, and it's really on the laboratories to be able to rapidly pivot to validate these methods to accommodate these matrices on the spot. Unfortunately, a lot of the industry operates in a framework where the clients of the laboratory do not give the laboratory very much heads up that a new product type is coming. So they could kind of turn around and be like, hey, we started making cookies this week and we need some results for it next week. That's a really quick turnaround. Additionally, the laboratory has to approach the state regulator and their accreditation body to make sure that they're capable of performing these tests. That turnaround time is often a lot longer than what the client expectation is. So we end up seeing in the industry a lot of variability between laboratory results. So one sample could be sent to 6 different laboratories and you get 6 different results. This has been an ongoing issue, and I wanted to kind of discuss the variability of methods that may be contributing to this issue. However, I will pause on this slide briefly because I do want to point out, and it's already been discussed here, that the sampling does have a significant impact on this. So in some cases, the processor or manufacturer is responsible for selecting the sample that goes to the laboratory. In this case, the laboratory has absolutely no control over the sample that they receive. So if the laboratory, and the one example where they have 0 CFUs, maybe the processor manufacturer just had the absolute cleanest part of the plant and it wasn't a very representative subsample of the lot or a representative sample for the whole lot. And so maybe that laboratory really did get a 0, and then the manufacturer selects a different portion of their batch to send to another laboratory, and they're getting very, very high microbial counts. As we know, the microbials are usually in like hot pockets in the batches. So it's kind of on the onus of the regulators to ensure that the samples that the laboratories are receiving are going to be representative of the entire lot, because otherwise this problem will continue to occur regardless of what the laboratory does once a sample is received. So I want to share some results from NIST's Canna QAP Exercise 2. These are available online publicly. I'm happy to email them to you if you can't find them for some reason. But this is about cannabinoid quantification for cannabis testing. And so there's basically a survey that's sent out to all of the participants about the types of methods that they're using. And so the respondents to this survey are then put into essentially little pie charts. So we can see multiple different variables within the methods that the laboratories are actively using. So most of these laboratories that are participating in this study are accredited for either hemp or cannabis testing. When it comes down to some pretty simple things like dilution, we see stuff like 100-fold dilution or more, all the way down to a 10-fold dilution and 5-fold dilution. Some of the participants did not respond to this. Also, some laboratories use multiple dilutions. We also saw that the extraction times varied significantly. So there are some laboratories who managed to extract in 1 minute, which is impressive, I guess, surprising. And then we also see up to 75 minutes of extraction time. So this is basically what happens when a tiny bit of a sample is diluted into usually like methanol or something like that. And then to make sure that all of the cannabinoids are actually extracted from the plant material, that can be vortexed or sonicated, which is basically like sending little sound waves through it to make sure that all the cannabinoids are going into the liquid component and then making it onto the chromatography instrument. The homogenization method was also queried. So some of the participants were cryo grinding, some of them were grinding with traditional grinders, but the vast majority were hand mixing the samples. We also did see some are cut with scissors. And then what was surprising to me is that over half of the laboratories admitted to not homogenizing the sample at all before putting it on test. So if that's the case, then they're probably not getting a very representative result for the sample that they have received in whole. Additionally, I did want to show that the laboratories were actually accredited for cannabis plant materials, hemp plant materials, so these are likely to be compliance laboratories. However, 29% were not accredited, so we are unsure about the source of those laboratories. Maybe they're university laboratories, research and development, or not involved with the compliance testing. The last thing I wanted to mention is a sample size. So we do see a sample size put on test all the way down to 0.04 grams, which is a very, very small amount of sample to be using. So in this case, again, that would not be as representative of the entire sample received, especially if the laboratory is not homogenizing and then taking like that little diamond part or the sparkliest part of the bud or the very top part that looks the prettiest and using that part for the test. On the other end of the spectrum, we did see a 2-gram sample size, which is pretty high. So that one may be possibly the most representative sample size to use, but then that puts kind of a constraint on the sample size that the laboratory needs from the client that they're working with. And generally, there are state requirements that kind of go into the sample size that should be used in this case. So some states may allow for this, whereas others may not. Additionally, there was a query about the reference materials that were used to create the calibration curves. So although more than half of folks did not answer this, people were using multiple providers, Cerilliant, Cayman, ResTech, and Shimatsu. And then the vast majority of the participants were using LC methods, although some of them were using GC. So just for potency testing, for cannabinoid testing, that kind of goes to show that the methods in use are extremely variable. There is really not a standard consensus method that is in place at this time, which may lead to some of the variability that we see in those results. The next topic I wanted to discuss was technology selection. So it can be really important for microbial testing, especially with these threshold tests like quantitative tests, total yeast and mold, total aerobic, which technology you're choosing to use. So there's an option to use live dead PCR, which essentially counts both the live and dead cells. There is live only PCR, which essentially cuts up the present DNA from all of the dead cells before quantifying all of the live cells that have DNA. So just between those two methods, there would be considerable difference. Then we have plating for 48 hours at 25C, plating for 72 hours at 25C, plating at 30C for 48 hours, and at 72 hours. So there are published studies, including in the Journal of AOAC, that shows that these are statistically significantly different. They're going to produce different results, and there are several species that are not going to be growing in cannabis matrix at 48 hours. However, these methods are still in use. The laboratories are still performing method validations on them. And from an accreditation standpoint, we cannot really go in and tell them, hey, you must plate at 25C for 72 hours. It's totally up to the laboratory what method they want to accredit. And as long as it matches the validation requirements that we discussed and they're following their method as written, there's really not much more that we can tell a laboratory about what they should or shouldn't do, because that would be considered consulting, which accreditation bodies are not allowed to do. There's also another technology called the most probable number. I don't think we see this quite as much in the cannabis industry, but it is another technology, so I did want to include it. And then lastly, for the Petri film, or I believe there's possibly options for all of the providers, but I know for sure that 3M has a plate counter that they can use. And interestingly, they do publish a table of the accuracy of their plate counter. So for laboratories that are using a plate counter, they may have up to 15% additional uncertainty for the result, as opposed to traditional counting by just having the technician essentially look at it and visually count everything. So while this may save some time, you may be sacrificing some of your accuracy when using a plate counter for some methods. So again, this is method specific, and 3M, or the manufacturer of the plate counter, will have that data for you to show you how accurate the plate counter is for the specific assay that you may be using. I also wanted to talk about just how this compares to other industries. So in other industries, we're really seeing a lot of standard methods that are already published. They've been published for years, potentially decades, whereas in cannabis, the standard methods are still in development. We're really only seeing them developed for cannabis or hemp flower at this time. We're not really seeing them for cannabinoid topicals and gummies and granola bars and everything else that exists. The manufacturer methods that are being used, like the ones published by Medicinal Genomics and other entities, are usually being used with little or no modifications. However, the laboratory is responsible to validate that that method works on all matrices that they are using it for. And not all methods published by manufacturers are necessarily fit for use on all matrices. The laboratory may actually have to adjust their approach in order to achieve accurate results. So for other industries, such as the petroleum industry, we can see primarily standard methods. These are all ASTM methods, ISO methods. There's some SOPs on here, but they are right next to the standard method, meaning that there's really no modification that's been made. Another example here, another petroleum laboratory. Again, all ASTM methods, pretty standard. We have a food testing laboratory here. They're all using AOAC methods across the board. So in this situation, what I kind of wanted to highlight was if you are a food manufacturer, a petroleum manufacturer, and you're selecting laboratories, you can tell exactly what method they're using. You know there's only one version of the ASTM method that's on that scope of accreditation. That's the method they're using, no ifs, ands, or buts. Another example where AOAC methods are being used for food products. This contrasts pretty heavily with the cannabis industry, where it says SOP something, GPA, SOP, SOP 800, not really any standard methods are being used. And part of this is not that the standard methods don't exist, it's that the standard methods are not required by regulators. And we did discuss a little bit yesterday in the panel that it's difficult for regulators to step in and actually require standard methods to be used, because that opens them up for potential litigation. There are some more examples just showing that cannabis laboratories are generally listing their methods by SOP number, which is not really clear to the regulator, to the client, to the consumer, what method they're using. SOP 800 could be pretty much anything. So there is some regulatory oversight needed, but it is difficult to make that happen, and of course a time-consuming process. So I think we're all here because, passion led us here. We all really care about making the industry a better place, kind of working together to harmonize the industry. And I think we can all kind of come together and find and fill the gaps and mitigate any overlaps. So in many areas, the state goes in and actually performs an additional assessment of the laboratory in addition to the accreditation assessment. In some states, there are significant overlaps in the assessment. And some state regulators may not be aware of the gaps in ISO 17025-2017 and may not be addressing these gaps appropriately, one of them potentially being with method validation. We also have the potential point of variability coming from certified reference materials. Please do go see Jeff Rawson. He's going to be presenting this afternoon in this room, 2:15. And that's a little bit about the variability that we see in certified reference materials, because we know that laboratories really like to say that that's where the variability is coming from, so we can look into whether or not that's the case. I did want to go through a couple proficiency testing results as well. So, a common complaint that we see is that proficiency tests are not offered at or around the action limit. So I hunted down one that was, just for fun. So I did look through multiple different reports. This one is Emerald's. However, just for comparison, NSI offers this test on etoxazole from 0.3 to 3 ppm. AOAC's is 0.12 to 1.2 ppm. Absolute standards is 0.05 to 10, which is a huge range. And Emerald's is 0.1 to 1 ppm. So in this situation, the assigned value is 1002, and the action limits are commonly around that 1000 level. So the vendor's assigned value says that, but based on many action limits, this sample should fail. However, only 3 of the participants would have failed this sample for etoxazole. So many of the laboratories at and around the action limits are not in agreement about the actual value there. There are some potential issues. However, even in this case, we do have most of the participants passing this with this. So this is another gap that regulators may want to consider, is the possibility that something that's at 1002 might be tested around an 8 or a 900, and the true value might be 1002, but the measurement uncertainty of the laboratory allows that result to be anywhere, between 800 to 1,100. So essentially, there's a big risk for a false fail or a false pass in these cases. Another kind of insane example that I like to highlight, and I've been highlighting for years, is there's really no standard method that's being used across the board for moisture, which is pretty upsetting because moisture is extremely important when it comes to what appears on the label at the end of the day in most states. Some states, actually, like Ohio, have decided that they are no longer going to be moisture correcting because the moisture correcting has such an impact on these final results. So if you're not familiar, the cannabinoid results and the terpene results that are on most product labels in the country are being corrected for moisture. So the laboratory is calculating how much of the sample that they receive, flower sample that they're receiving is water. That water percent is subtracted, and then you get the percentage after that. So the methods that are being used in this proficiency test, which is by ASTM, which they also collect a lot of information about the methods that are being used. The oven temperatures ranged from 40 Celsius to 110 Celsius, and the oven time ranged from 3 minutes to 4 hours. So that's exciting. We also saw, I didn't say it, but the passing values were 4.16 to 13.26. So just to kind of show you what that conversion really looks like, if you're testing hemp, that really could be the difference between destroying an entire lot of hemp or the hemp making it to the marketplace. If you're testing cannabis, that really could be the difference between price point at a dispensary, and it could be the difference between a product that sells or doesn't sell. Unfortunately, we do exist currently in a world where THC has been prioritized pretty heavily. I'm not saying that that's correct. I just wanted to show an example of how it impacts results. And just as a note, this percentage, it impacts results across the board, but it's going to impact results more when the actual result is higher. So as the THCA or CBDA numbers go up, the impact of the moisture percent conversion is going to be greater. This contrasts with another ASTM study that was run for proficiency testing on dry distiller's grain. So in this example, all of the laboratories were using a standard method because a standard method has existed and it's been validated and optimized for a while. So you can see in this that the standard deviation on those are considerably lower as compared to the hemp flower. I kind of like to let this simmer. I've had this kind of slide for 3 years, and we still are kind of seeing the same issues being highlighted. A lot of folks are talking about lab shopping, and hopefully this presentation kind of shows you one aspect as to why that's happening. Of course, there's financial incentives. Of course, there's other factors and variables going on, but like in that slide, if if you send one sample out to 6 different laboratories and they're all using a different method for total yeast and mold, you could really be getting some pretty variable results, even if the laboratory is not acting nefariously. So what does this lead to? Essentially, consumers lose faith in the data on the label. We have Jeff Ross's Institute of Cannabis Science showing that off-the-shelf testing failed microbial limits at 3 laboratories despite passing the third-party testing. We also had Bubba Kush Blackstone Valley labels listed at 32% THCA, and subsequent testing revealed a 20 to 25% THCA. NBC Bay Area, the homogeneous samples were tested by 10 laboratories, and the range was 64 to 83%. We also had Dr. Anna Schwabe perform off-the-shelf testing in Colorado and MedFarm perform off-the-shelf testing in Colorado, and both of these studies showed that the potency as advertised on the label was significantly different than the detected potency that the study performers found. An additional example of this was Havard Industries in Oklahoma has done a study where they have tested pre-rolls off the shelf in Oklahoma and found that the vast majority of them were failing for microbial limits based on the method that they're using. Now, this doesn't prove necessarily that the methods that are used in the studies were the best and brightest methods ever and they're absolutely perfect and there's no uncertainty and they're the best. It just means that the methods that are being used by the people performing the studies are significantly different than the methods that are being used at the compliance laboratories. And this is definitely concerning when you're a manufacturer or processor. So how do you choose a laboratory? It's kind of hard because you have to look in and really dig and ask questions to the laboratory that you're choosing to work with. What methods are you using? What is your measurement uncertainty? Can you show me your quality control? These are important questions to know the answers to, because when your product gets recalled and you end up potentially in a court setting, you want that data to be legally defensible. So this is really important for cannabis because standard methods, even when they are published, it's difficult to make sure that they're being implemented and enforced. Regulators may rely on passing proficiency tests, which we've shown is pretty easy to do, and becoming accredited, where the validation requirements for accreditation are possibly not as stringent as the industry would like them to be. The method validation requirements are to the extent necessary, which has a pretty significant impact for barrier tests like total yeast and mold and total aerobic count. And additionally, the determination of the assigned value may be difficult for the proficiency testing provider when the results that they are getting in from the participants vary so wildly. Especially when it comes to the total yeast and mold tests, it's very difficult. And I've talked to some folks that run proficiency test programs. They say, you can drive a plane through the data, you can land a truck, or you can drive a truck through the data. It's really hard for them to take in the data and determine what should pass and what should fail. And a lot of them are relying on Z-scores. Additionally, a concern that we have seen and talked about, new analytes of interest may arise at any time. We've heard about some synthetic cannabinoids that may be present in products that laboratories are not currently accredited for. We've heard about potential mycotoxins that might be present in the flower that we're not testing for. So if we're already behind, we're just going to continue to become more and more behind as these new analytes of interest come up. So as a total summary, the accreditation does provide assurance that the laboratory is competent in performing the methods that are on the scope of accreditation. Although the methods are on the scope, that doesn't guarantee that the method from one laboratory and another laboratory are going to be equivalent. Other industries rely on standard methods with rigorous validation to solve this issue, because if you're in the food industry, you can look in every scoped test is going to be the ASTM test or the AOAC test, so you know exactly what method the laboratory is using. The validation requirements additionally vary significantly between the states. And the industry is behind just on flower tests. The last thing I want to point out, simple acceptance. So for those who don't know what this means, basically every data point, every time you use a pipette or a balance or a CRM or anything, there's a tiny little bit of uncertainty that comes along with that measurement. These kind of accumulate into a total measurement uncertainty for a method. So that measurement uncertainty can be upwards of 20% uncertainty. And it's not common that this measurement uncertainty is taken into account when pass-fail decisions are made. So there is a significant risk of false pass and false fails in this industry that should be addressed by regulators in some capacity. Some solutions, communicate with your regulators, communicate with your dispensaries. If you're a grower and processor, communicate with your labs. Develop and optimize some robust standard methods. Join organizations like AOAC and ASTM, ACIL, and NCLC. Help future-proof the cannabis industry. Let's get together and fill the gaps. And please have a wonderful time at CannMed. And if you have any questions, please ask them. Also, these are my dogs.
All right.